My name is Zach Emmerich. I am a Principal Systems Engineer with the Mid-Atlantic team. Today we're going to be discussing TLS traffic inspection on the AOS-CX 10.16.1006 firmware. Our agenda is a brief overview, use cases, details and caveats, configuration, best practices, troubleshooting, a feature demo, scalability and performance metrics, and a few additional resources. Traffic inspection involves analyzing network traffic to identify and block malicious activities. Traffic inspection in our AOS-CX switches allow a customer to inspect traffic for authenticated clients to identify malicious signatures. The feature inspects TLS packets only today and only in IDS mode. We do not enable IPS mode today. Packets are copied but not stolen from the CPU. That way we just make a duplicate of the packet. We do not drop it in any way. Today, again, only the IDS functionality is being utilized. We use the Proofpoint ET Pro rule set. It's an accurate rule set designed to detect and block advanced threats using existing network security appliances such as network intrusion detection and prevention systems, aka IDS IPS. It is a subset of the rules used in the AOS-CX implementation of Suricata. Suricata is a free and open source network threat detection engine. It can act as both an IDS and an IPS, but again, today we are only using the IDS feature set. AOS-CX 10.16.1006 supports 10,969 rules today, so it is quite comprehensive. For platform support, today we support the 6300 and the 6400 V2. We do not support the 6300L as of yet. There is an advanced feature pack that is required. This is a net new feature to AOS-CX. Again, we only detect, we do not block any traffic. The initial flow packets are copied to the traffic inspection engine, again, so we don't drop any packets on the wire. Traffic inspection can be enabled per role. VSF and VSX is supported because Suricata runs independently on each individual switch. Inspection is only enabled on edge ports. So I would like to highlight the advanced feature pack is in line with the advanced license in Aruba Central. So if you're not managing it in Aruba Central, you must have the advanced feature pack. If you are in Aruba Central, you will need the advanced license for that model switch. So a few use cases. One, today you can identify clients that may be compromised or are sending traffic to malicious targets, as we have highlighted in this screenshot. You can tell the destination, you can tell the signature ID, that's the Suricata rule set ID, and the category that was matched. So this provides higher fidelity traffic analytics for wired clients that we've only seen on the wireless side up until this point. You can also export this information to an external tool such as a SIM. So here's a simple snippet to show how you can export this information to a syslog. I made a very simple filter here that just excludes OSPF logging because it can be a bit noisy. And then I enable traffic inspection all with the debugging option. And then I specify the destination being syslog. And down below, you can see the information that would be sent off to your SIM. Now I've highlighted that there was one alert that was triggered by this specific MAC address, and that is being processed by the switch, and then that will be sent off to your SIM. So a little more detail. Advanced feature pack is required, and again, in Aruba Central, the advanced license will be required. Our integration of Suricata uses version 7.0.10. Suricata and the rule set is updated via switch upgrades only. The engine and rule set are upgraded together, and they cannot be updated manually. Again, there's 10,969 unique rules from the ET Pro and Suricata TLS events rule set. We utilize JA3 and JA3S fingerprinting during TLS handshake for behavior analytics, so we're not relying just on the SNI and the certificate. Both IPv4 and v6 are supported. TLS traffic for all clients is inspected by Suricata, even if just one of the clients on the port uses a role with traffic inspection enabled. However, alerts generated for clients that do not have traffic inspection enabled in their role are discarded and not published to the database. What this means is that multiple clients on the same port will all, if even one of those clients have a role enabled for traffic inspection, all of the clients on that port will be inspected, but only the client with the enabled role will be reported on. Flow tracking is a prerequisite. Very simple, flow tracking enable. Application recognition is not required. Excuse me. So here is an example with a packet capture of one of the rule sets that is being triggered, or one of the alerts that's being triggered. The way we implement the alerts is we make the external and the home net variables that you can see in the example on the left. We make those both the same, basically any. So we detect traffic in both directions. With this specific alert, we are looking at the SSL certificate serial number, and you notice in the Wireshark capture that this packet does match that serial number, and then an alert is triggered on the switch. So more details. This is the output that Suricata reads whenever an alert is triggered, and there's a few things that I wanted to highlight. One being that the direction is any. The other being that the action is always going to be allowed. Again, we do not drop any packets today. We just want to alert on them. More functionality will come in the future. So local user role, some prerequisite configurations. We must disable IP source lockdown resource extended. That is to give the traffic inspection engine access to the packet, essentially. Flow tracking must be enabled to track the individual flows. Traffic inspection, inspect TLS, enable is all that's required to enable the traffic inspection feature. There is a call out here that we inspect TLS today, but the list of supported protocols is expected to grow. For the role configuration, you enter the role context and then traffic inspection enable. Downloadable user roles are also supported. The same configuration must be put in place, and then below you can see a example from the ClearPass side of how to push the needed configuration for traffic inspection to be enabled. Some equivalent configurations. Again, this is the AOS-CX configuration. Today, Cisco IOS does not support this natively. They require the Cisco Next Generation IPS. AOS-CS, our ProCurve line, is not supported, and it is also not supported on the CommWare switches. So some best practices. We must disable application recognition fast mode. Very simple. App-recognition, no mode fast. If app recognition is enabled with fast mode, traffic inspection may not receive all of the packets of a TLS handshake to identify threats. Some troubleshooting commands. The first one, show traffic inspection, simply shows that is it enabled, what classes of traffic we're inspecting. Today that would only be TLS, and then some statistics on what we have seen so far. Here is a snippet of what has been identified on this switch. And then we want to show flow tracking to make sure that is enabled, and mainly, or possibly more importantly, the operational status. It is also enabled. And down below you can see the specific interface where traffic inspection is enabled. Now this doesn't mean that you need to enable traffic inspection on the port itself. This is indicating that there is a client that has been assigned a role with traffic inspection enabled that's connected to this port. More troubleshooting. So here we're showing the actual role named default, and we highlight here that traffic inspection is indeed enabled for that specific role. And then we're showing port access traffic inspection details, where we can get more granular details from the client name to the source to the destination, and again the category, severity, and how many times this alert has been triggered. Show port access clients interface 1113 details. This will show the specific details on that port. We see that there is at least one client with the role default applied, and traffic inspection is enabled for that role and thus that client. Here's an output of the TIPS 10SP Assist D daemon, which is our traffic inspection daemon. So I highlighted here in bold that the inspection engine is operational, status is up, and a few other debug events that are being triggered. And below that there is show debug buffer reverse module traffic inspection. And I've highlighted here that one alert has been triggered for this specific MAC address. And this is what you'll see in the debug logs every time an alert is triggered. So show capacities traffic inspection. Today we support 256 individual threats per client. Once the client hits the 256 limit, they will be disposed of in a first in, first out manner. So let's switch over to a featured demo. So now we are in the switch configuration. Let's go ahead and get the traffic inspection feature configured. So let's first check to see if traffic inspection is enabled. And we see that it is not. Is traffic flow tracking enabled? So we can see it is not. And let's check our role that we're going to be demoing to see if it is enabled there. And we do not see the keyword traffic inspection, so it is not enabled at the role either. So let's prep this a little by enabling some debug. And as you remember from the slides, we must disable IP source lockdown resource extended. Now let's enable traffic inspection. So once we're in the traffic inspection context, we need to tell it what traffic to inspect. And then we just turn it on. And this is warning us that flow tracking is not enabled and that we must enable it. So let's back out of here and enable flow tracking. This is not required, but I always like to enable it. Now let's go back to traffic inspection and re-enable it. Inspect TLS, enable. Now we didn't get our warning that flow tracking was disabled. So our next step is we must configure the port access role to enable traffic inspection for that role. And that is it. So let's do some verification. Show traffic inspection. We can see that now it is enabled, and the traffic class we are inspecting is TLS, and we have no signatures or alerts that have been triggered just yet. Let's check flow tracking. We can see now that the configuration status is enabled, the operational status is enabled, and we see that traffic inspection is enabled on 111. Again, this does not mean that you need to enable traffic inspection at the interface. It simply means that there is a client with a role that is attached to 111, and that role has traffic inspection enabled. So let's verify our role. So we have the name default and traffic inspection is enabled. Let's do show port access client detail. So we are getting a MAC address. We're doing some profiling to determine this is a Raspberry Pi, and again, traffic inspection is enabled. So at this point, I need to generate some traffic to trigger the traffic inspection engine, and I'm going to go ahead and do that now. There will be a short pause. So I've generated some traffic from our client here. So if we just run this command one more time, show port access clients detail, now we can see that an alert has been triggered, and there has been one hit for this specific alert. We can further verify by just doing show traffic inspection. So this view would give you a global view of the switch, where the previous command would give you a breakdown per port, per role for each individual client. If we look at the debug buffer, we can see that there, if I can find it here, so here there is a alert added for this specific MAC address, which was then added to a alert file and then published to the database. So the way Suricata works is it'll be published to this JSON file that's listed here in the, and I apologize that the output is being wrapped. Once this is read by the Suricata engine, it's then added as an alert to the switch itself and then added to the DB for processing and display to the end user. So if we go and show port access clients interface 111 detail, and we can again see there's just been one hit. I tried to generate some more traffic, but I didn't want to prolong the demo longer than it needed to. So that is about it for the demo. Be a short pause and we'll get back to the presentation. So we're back and we're going to review the scalability and performance for the traffic inspection feature. For the 6300, the threats can be 256 per client. Again, that means that each client can have a max of 256 flow threats, and once they hit 257, they will be removed from the database in a first in, first out method. This metric is the same across the 6400s as well, with the Access LC and the Core LC. CPS for the 6300 is 500. The 6400 is 500 per LC. For the flows monitored, there will be up to 24,576 for the 6300. The same per line, same per LC for the Access, and 60,000 per LC for the Core LC. The COP rate will be 3,500 across the board for each of these three models. And that will conclude today's demonstration.